if it's okay, I'm gonna start recording now, just so that we, yeah, so that we have reference to it. I think mo almost every single person in the class is actually on the Zoom right now, so this may be redundant, but that's okay. It's better to have it and have it recorded. So I'm gonna share my screen and shrink this and shrink this and shrink this and, and shrink this. What the fuck is that? Okay, so I want to talk about fossil fuels in general. Just this lecture I never really know where to put it because it's like kind of like a weird intro level, and it bridges between the Exxon Valdez oil spill stuff and then our larger, broader discussion of climate change. So I'm sticking it in here. I'm still unhappy about it, but it is what it is. So let's start. Oh, sorry. Hang on. I want to do this. All right. So everyone can see my screen, right? Yes. Okay, cool. So I just want to like really briefly talk about fossil fuels. So we're transitioning from our discussion about the nuclear disasters and Chernobyl. We spent a long time on that, and now we're going to talk about fossil fuels. And then your homework assignment is going to be kind of comparing and contrasting the two as like a future sort of which one's worse. That's a very simplistic framing, but the assignment explains it better, and I'll post it if it's not already posted. I can't remember if I posted it or not, but I will do that. So fossil fuel extraction, right? There are three main types of fossil fuels. Oil, well, three broad categories of fossil fuels: oil, natural gas, and coal. And so your group work this week actually will be to just kind of do a very broad overview summary of like one of these. Each group will get either coal, natural gas, or oil, like where it comes from, how much of it there is, how it's been extracted, what the history of it is, and what the future is of that fossil fuel. So I'll explain that in a moment. But just kind of broadly, you can see that most of the fossil fuel resources are located in the global north. For example, oil, there's a lot of oil in Canada and Russia and the United States, as well as the Middle East, OPEC countries. Natural gas, there's a lot of natural gas in the US and Russia. And then coal, there's a lot of coal in the US and Russia. And one of the reasons that for most of the 20th century, the US was an empire is because of our access to all of these fossil fuels. So here are just some more maps. Gas and coal have really been the big winners, so to speak, for the United States. And so this map up here shows gas production in conventional fields, and most of that gas production is actually being produced and extracted through a process known as fracking. And we're going to talk about, we have a whole class on fracking coming up in, I don't know, a couple weeks. This is an expansion on this, showing where the sort of natural gas fields are throughout the globe. So you can see there's a lot in the US and Russia and Northern Europe. There's a bunch in the Amazon that are, as of yet, like haven't been accessed yet for economic benefit. This map here shows the coal reserves, and you can see that they overlap somewhat with the natural gas reserves, especially like in Siberia and in sort of the Western North American region, as well as like the Appalachian Mountains. There's also a lot of coal in China and Australia. Yeah, so where are they located in terms of natural gas? Most of it's in Russia and the United States, China, Iran, and then the usual suspects. We'll talk about this later. This is yeah, so the next lecture will be on like the links between capitalism and fossil fuel extraction. And I only have this slide in here to kind of draw your attention to this book, Fossil Capital, which I actually have over here. It's in the bottom of my bookcase. It's too low. I don't want to deal with it. But this is what the cover looks like. And it traces the history of fossil fuel extraction in the global north and how capitalism and fossil fuel extraction are inseparable at this point. So if you want to solve climate change, you can't really do it through capitalism. It's not possible because they are, at this point, kind of inseparable, right? Like modern capitalism, whatever that is to you, it's not really like a thing. It's just a system that we created, but is reliant on the extraction of fossil fuel and cheap exploited labor. At one point, that cheap exploited labor was enslaved peoples. So those are the two sort of like tenets of capitalism. And so if you're going to solve the climate crisis, then you've got to sort of in tandem deal with the capitalism problem. And so I will talk about this in more detail in the next lecture, which I'll post next week, which kind of talks about the link between the historical link between the rise of fossil fuel extraction and coal and its relationship to capitalism. And it all is traced to sort of the invention of the steam engine by James Watt, but it's not as simple as just that. So Watt invented the steam engine in the late 1700s, but it wasn't an immediate reason why we switched globally from using water as a power source to using fossil fuels, to using coal, oil, and natural gas. It was a number of different reasons, like an economic depression and capitalism sort of forcing our hands, mainly because the main sort of take-home message is that when you use fossil fuel, when you use coal as an energy source instead of water, you can control the labor market more fully, right? You can control people's labor, which is a limited resource. It's actually like, the limited resource to capitalists. And so I'll talk about this in more detail next week, but just to kind of entice you a little bit to think about these types of things. So the book is called Fossil Capital by Andreas Malm. So why are fossil fuels, why do we use them? Like what is the benefit of using coal or gas or oil to produce energy? Like, how do we do that? And the main way we do that is through combustion. So combustion is when a hydrocarbon, oil, gas, or coal, is burned in air which has a lot of oxygen. So the chemical equation is here. CXHY is a random hydrocarbon, like oil or gas or coal or whatever. And then you add to it a bunch of oxygen, right? Very quickly, which is what happens when you light something on fire. So you essentially light the coal on fire. And the byproducts are carbon dioxide is a waste product. Water vapor is a waste product. So normally when you look at these smokestacks and you see that plume of smoke coming off the top, some of that is like soot and whatever, but a lot of it is water vapor or steam. And so in addition to the carbon dioxide and the water vapor, the other byproduct of this chemical reaction is a lot of heat energy. So you add hydrocarbon, like oil, and then you add oxygen to it, and you get carbon dioxide, water vapor, which are waste products, and then energy. And we're really after that energy, that heat energy. And so what happens with that, and there's a YouTube video here that shows what combustion is, and I'll post this. So what happens with that energy is as follows. So we take the coal. This is a modern steam engine, if you will. This is a coal power plant, but the basic tenets of all of these operations are the same, right? You're transferring the heat energy from burning coal into electrical energy. And here's how it happens. So you take the coal and you put it in a furnace in a power plant, and you burn it. Running through that furnace is a pipe full of water that's being pumped from a river or a lake or a holding tank. So it's just water, clean water. It's being sent. You cool it first, right? So that it's like a reasonably cool temperature. You condense it, and then you run it through the pipe that runs through the furnace. The heat that results from burning the coal heats up the water in the pipe and turns it from liquid water, condensed liquid water, to gas, to steam and gas. And the force of that steam, right, which is moving now quickly because it's warmed up and it's steam and it has to go somewhere, runs out of the furnace through a pipe, and the force of that steam pushes a turbine. So the steam is pushing some kind of turbine, and as the turbine is spinning, it's generating electrical energy. And that's it. Does that make sense to all of you? Does that kind of like general mechanism make sense? So yeah, so you just are taking the coal, putting it in the furnace, burning it. The water that's running through that furnace is turning from liquid to steam. The steam is pushing a turbine, and the turbine is generating electricity, which is sent out to, you know, power lines and your house and that sort of thing. Okay, and then this introduces the group work that you'll do this week, basically taking one of these fuels, whether it's oil, natural gas, or coal, and create just like a 1 or 2 PowerPoint slide explaining where it's found, how much is left, how much has been burned, how it's extracted, what percentage of global energy use it accounts for, yada, 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 et cetera, et cetera. Just interesting stuff that we can have as reference as we start the next couple of weeks thinking about the role of fossil fuels. And I'll screenshot this and post it to the Discord. All right, so I'm gonna stop sharing this, and I'm gonna stop recording.